Alright, so looking at section 3.5, this is about solving nonlinear systems. So remember, a system just means that we have more than one equation. So see, these are all systems because we have two equations. So what we're supposed to do here is we're supposed to work together, and we're going to match each of these systems with the graphs down below. So I'm going to do one with you. I'll actually do the first one with you. I can look at this function and I know this is a parabola with a vertex of 0, 0. And I know this is a line with a slope of 1 and a y-intercept of 2. So I go down here and I'm looking for a parabola and a line. So the ones that are a parabola and a line would be that, this, and this. These are the only three. And then I knew that my parabola had to have a vertex of 0, 0. Oh, somebody left in the lane, please. Michaela just let her in, or somebody. So then we're going to have a parabola right there and a line right here. And so then that's going to mean that this is going to be A. Okay? So take a couple of minutes. You can work with your group and try to match these up, and then we're going to go over them. Alright, so let's talk about it. I know you may not be completely finished, but by process of elimination you can probably figure them out. So what did you get for letter B? Sydney, what did you get? E? Do we agree with E? Yep, that's right. Maya, what did you get on letter C? F? So F is a line and a parabola, so that should work. So we've done these. So now we're looking at letter D. And Natalia, what did you get for letter D? B? Sounds good. One should open up, one should open down. You can check those vertices to see if it was correct. Becky, what did you get for E? C? And then we only have one left. And so this one had to be D. Okay? So what we also will be wanting to do with these systems is we want to find out what's the X and Y value that would make both of these true. So like for the first one, I know 1, 1 makes this true, but does 1, 1 make this true? No. I can see that 2, 4 would make this true, and 2, 4 would make that one true. So if I look down here, I can actually see that this right here, that's going to be a value that makes both of them true. Can you see how that's going to be a 2, 4? That's going to be one of our solutions then, 2, 4. One of our other solutions would be right here at -1, 1. So that's a way that we can solve systems, is by just looking for those points of intersection visually. And we could go through and do that. All right, let's take a look at the next page now with the actual notes. There's really nothing for us to look at until we get to page 68. So turn over to page 68. So one thing we want to be able to do is to solve by graphing. Now if I ask you to solve by graphing, doing it on a piece of graph paper really isn't accurate enough. We're just going to use our graphing calculator. So let's do number 3 right now on our graphing calculator. So what we want to do is go to y equals, clear it out. We're going to look at the first one. Make sure that you don't push, sometimes people push a minus when they really mean the negative. So make sure you hit the negative key and put in negative x squared, then minus 2. And then in y2 we want to put in 4 parentheses x plus 1 minus 3. And then we'll do a zoom standard, zoom 6. And here's the way it looks. So we want to find those points of intersection. It's really hard to see them. There's really 2 of them and it's hard to see. So what I'm going to do is I'm going to go to my window and I'm going to zoom in a little bit. I'm going to make it go from like -4 to 4 and -4 to 4. That's going to make my window a lot nicer. Well, maybe not. Let's change it again. I need to go down further. Let's make it like -8. See how that does. Okay, so we'll see what happens. We can definitely find this point of intersection. So we're going to do second, trace, intersect, and we just get close to that intersection, enter, 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 and we get -1, -3. That's one of our solutions. The other solution's pretty far down there, and I can't really see it. I'm going to have to go down even further than I thought. I might even want to make this -15. Let's see what happens. All right, so I want to find this point way down there. So second, calculate, intersect. We've got to get down close to it. Otherwise, it's just going to find the same one over again if I don't get close to it. Calculator's smart, but not that smart. Can't read our mind. So the other one is -3, -11. Okay, makes sense? We've done things like that before with lines. No problem. All right, now what about 4 and 5? It says to solve the nonlinear equations, that system, by using just the graph. Well, that's what I was showing you on the other side. You should be able to find these 2 points. Go ahead and find those 2 points. Tyler, were you able to find them? Well, actually, look at what this is saying, though. This is -4 right here, so it's actually going by 2s. So what's it going to be instead? Hello? Hello? Uh-huh. Yes. Okay, so we've got -1, and then this is going to be 4, 6, 8, 10. So -1, -10. Okay, and then this is going to be what then, guys? 2, -10. Okay, so those are going to be the solutions to that system. What do you think the solution is going to be here? No solution. There are no values that are going to make that true. All right. Solve by substitution. Okay, well, we could do that. But look at this problem right here, guys. Solving this by substitution would mean wherever we have a y down here, we're going to replace it with this. So we would get that. Then to solve it further, we would get x plus 4 equals, we're going to square this out, x squared plus 4x plus 4 plus 1. Setting it equal to 0, I'm going to get x squared plus 3x. That's 5, and then I would have to subtract 4. So 5 minus 4 is going to give us 1. How are we going to solve something like that then? Anybody know how I'd have to solve that? With the what? Completing the square or quadratic formula. It won't factor. So I'm going to have to do x equals negative b plus or minus b squared minus 4 times a times c all over 2a. Now, we're getting some strange answers, so we might want to check this on the calculator. So if I just put this in, x plus 4, and I put in the other one, x plus 2 squared plus 1. I just want to see what this looks like. So here's the line. There's the parabola. There are two solutions. I want to find one of them. Just to make sure we're on the right track. Okay, so because of these types of answers, I know I'm on the right track. How do I know it's going correctly? What types of answers are these? They're decimals, they're irrational, so I'm probably doing this correctly. So we're going to have x equals negative 3 plus or minus the square root of 5 over 2. So that's going to be our x value. And then we would also have an x value of negative 3 minus radical 2 all over 2. And then to find out what y is, I have to add 4 to it. This is a really tough one. So we're going to have negative 3 halves plus radical 5 over 2, and I'm going to have to add 4 to it. Do you see how I'm adding 4 by calling it just 8 over 2? So that's going to be 5 over 2 plus radical, 5 over 2 plus radical 5 over 2. And then I also have to plug in the negative of this, which is going to be the same answer, but that's going to be a minus. Alright, so pretty tough there, but that would be it. Okay, let's do number 7. Number 7 by substitution. This is already solved for y, so we're going to go ahead and plug that in. So I've got x squared. Here's where people always make a mistake, is squaring this binomial. A lot of people just say, oh, it's x squared plus 16. That's not right. To do that, you have to do negative x plus 4 times negative x plus 4. You got to do it like that. So negative x times negative x is x squared. Negative x times 4 is negative 4x. Another negative 4x. And then 4 times 4. So we get this. So x squared plus x squared is 2x squared. Okay, so we get this. And now we have to factor out a 2x. And so what are our two answers for x then going to be? Joey, what are they? No, just, you've got it factored, so you've got to set this equal to 0 and this equal to 0. 0 and positive 4. So those are going to be our x values. And then to find our y values, we can just substitute in anywhere. Let's go ahead and substitute into the second one. Michaela, what am I going to get if I substitute into the second one? I'm trying to plug back in to find out what y is when x is 0, which is, so we get 0, 4, and now plug this in. And so those will be our two solutions. We're not going to bother with this one by substitution. It doesn't look too fun, does it? Alright, let's go over then to the next page, how we can use elimination. Alright, let's do this one first. The reason I want to do this one first is because everything matches up. All of the terms are already in the correct order. So if I want to use elimination, all I'm going to do is multiply my second one or my first one by -1. I'm going to do the second one by -1. Because elimination is how we did the problem in our warm-ups. I can just multiply or add straight down now. So y minus y is 0. 9x squared minus 1x squared is 8x squared. 6 plus 8 is 14. 2 plus 19 is 21. So I might want to see then if I can factor this to solve it. If I can't factor it, I can use the quadratic formula. I can also use my calculator to solve it. I'm going to use my calculator this time. I'm going to show you another way you can use your calculator on this. So we can go and type in 8x squared plus 14x plus 21. We're going to do a zoom 6. Okay, so do we have any places where it equals 0? No, we do not. And so what's the answer to this then? No solution. Look guys, if I started using the quadratic formula, I would get x equals -b plus or minus the square root. 14 squared is 196 minus 4 times a times c. I don't even need to finish anymore. Because look at this. This is going to be 32 times 21. Is that going to be more than 196? Yeah, it definitely is, isn't it? So therefore, I know that this is going to have an imaginary part to it. So whenever that happens, we're going to have no solution. And we're looking for a point of intersection. So we don't even have to say no real solution. This is no solution at all. If you're trying to find the points where these intersect and you get a negative under the radical, there is no solution. We can verify that by looking at the graph. Okay? I also could have looked at the graph like this. I could have just typed in the original functions. So I could have just typed in 9x squared plus 6x plus 2. That was my first one. My second one was x squared minus 8x minus 19. Those are my equations. And then when I look at these, here's the way the two look. There's one of them, and there's the other one. Can you see how they're never going to meet? So that's another reason why there's no solution. All right, let's actually do one now where it works out okay. Let's go back to number 9 now. So I need to get number 9 into a good order where everything matches up right to use elimination. So I'm going to do x squared minus 7x. I'm going to go ahead and bring over the y and put minus y. I'm going to bring over that constant, so I'm going to have plus 12 equals 0. And then I'm going to do the same thing here. I've got a negative x plus y, and I'm going to bring over the constant so that they line up. So I have to get it so that everything lines up. The first thing I'm going to try to do is just add them and see if one of my variables will go away. You can see if I add these, x squared minus 8x, that's going to be 0, that's going to be 16. So it does work. I now have a function that I can factor. Do you know how that factors? It's a perfect square trinomial. What is it, guys? So it's x minus 4 quantity squared has to equal 0. I take the square root. X minus 4 has to be plus or minus 0, which is just 0. So x equals 4. So I know they're going to have to intersect at 4 comma. How do I find the corresponding y value? Yep. I'm not going to plug into the top. That looks pretty confusing. Plug into the next one, though. I have negative 4 plus y equals negative 4. So what's y going to have to be then? 0. So just one point of intersection. Is it possible for a parabola and a line to have one point of intersection? Yeah. Look. See how that would have one point of intersection? So that's possible. I knew this is a parabola, this is a line. Okay, we're not doing 11, we're not doing any of this. I want you to go down to the bottom to number 12. Okay, so it says the sum of two numbers is -5, and the sum of the squares of the two numbers is 17. What are the two numbers? I want you guys to think about that for a minute. How can we write equations? And we're going to say x is our first number, and y is our second number. Let's see if you can write some equations there. Charlie, do you know an equation we could write? Okay, what does the sum of two numbers mean? Does it mean you multiply, add, subtract? Okay, so here are our two numbers. So to write the sum of those two numbers, that's x plus y. And then what does it have to equal? Right. Then it says the sum of the squares of the two numbers. How do I write the sum of the squares of the two numbers? Do you know, Abby? Good. Okay, so that's what we get. So now we just want to decide, are we going to use elimination? We can't use elimination, can we? Because nothing's going to cancel out. So we're going to have to use substitution. So we'll just go ahead and solve this for x. So x would equal -5 minus y. So now down here, wherever I have an x, I can replace that with -5 minus y. And then we're going to have to square it. Plus y squared equals 17. So to square this, I can't just square this and square that. That's what everybody always does, and it's wrong. You have to do -5 minus y times -5 minus y. So that's going to give us 25. That gives us positive 5y. That gives us positive 5y. That's positive 10y. Negative y times negative y is plus y squared. Then we have to finish writing. So that was just that part. Then we've got plus y squared equals 17. And so that's what we're going to have to solve. So we're going to have y squared plus y squared is 2y squared. And subtract your 25, and that's 8. So what can we divide everything through by? 2. So we're going to have y squared plus 5y plus 4 equals 0. Does that factor? How's it factor, Drew?
X plus 4 plus x plus 4.
Okay, it's actually y though, isn't it? Okay, so then that's going to tell us that y has to be -1 or -4. So those are going to be our y values. Be careful that you put them in for y and not x. And now I just have to substitute back in. So I'll just substitute in right here. X has to be -5 minus -1. So what's that going to be, everybody? -4. X is also going to be -5 minus -4, and that's going to be -1. And so those are our two values that are going to make that true. Okay. Any questions over that? All right. Good job.